turn a pencil into a diamond? After all, they are the same thing, carbon. So can you turn one into the other? 100% if you have this expensive machine. But if you're poor like me, the question becomes, can you do it at home? Yes? But outside the house, and only if you do this. But before digging into the secret to transform cheap pencils into expensive diamond, let me break the science behind it. Don't you dare click away. To understand why your pencil won't magically become a diamond, we need one secret equation. But first, let's burn the diamond. Yes, you can burn them. I think this is the only time I don't have to say don't try this at home. Even though I don't know who would be the crazy one to actually do that. Probably a billionaire. Anyway, you set it on fire and it turns into gas. I'm serious. When you burn a diamond, it turns into carbon dioxide. So you end up with literally nothing. But you not only lost a lot of money, you also paid to destroy it by consuming a lot of energy. And the total amount of energy that you consumed is called enthalpy. Out of this energy, a part of it was used to change the structure of your precious diamond into carbon dioxide. And the energy you're left with is the only energy that you can physically use to do something, what scientists call useful work, like pushing a piston with a gas. That would be a very expensive fuel. And that energy is called Gibbs Free Energy. I actually have a whole video explaining this in more details. Link in the description. For now, the only thing you need to know is that enthalpy change is like your salary, entropy change is like the taxes, and Gibbs energy change is your net salary. Society stuff, especially if your taxes are used to pay something very useless. But anyway, we only care about differences of these things. We don't care where the energy went throughout the whole process. That's why they're called state functions. So why is Gibbs Free Energy so important? Because it's the thing that decides what happens and what doesn't. If the change is negative, it means it can happen. But if it's positive, it cannot happen, unless you push it artificially. And this is the case of our pencil. Spontaneously, it will never turn into a diamond. Not even if you wait 1 billion years. But we can do it with the big push. Just like the Earth does. If you dig a 225 kilometers hole into the Earth, 140 miles for my American friends, the conditions there are so extreme that delta G becomes negative and diamonds form spontaneously. Okay, but we don't want to dig that hole. We want to turn our pencil into diamonds at home. And this is how we do it. This is how we do it. What song was that? Who was the author? I don't remember. To switch delta G from positive to negative, we need to create similar extreme conditions like in the Earth. How do we do this? We do it by changing two variables, pressure and temperature. To switch Gibbs Free Energy, we need a pressure of 60,000 atmospheres. That's like 200 buses on a pencil. I know it's scary, but I promise it's gonna be worth it. I told you had to do it outside the house. Or, if we only use the tip of the pencil, we only need 3 buses. But then we need to increase the temperature a lot. We need to go to 1500 degrees Celsius. It's like 2700 something Fahrenheit. America, why do you have this? Why? Everybody in the world has Celsius. Please convert yourself. Anyway, so we need a big oven. Just remember to remove the tires. You don't really want to breathe the gases that comes out of them. And then you just wait some hours and ta-da! Here is your diamond. I wonder if Mark Robber will try to do that. That would be cool. Mark, if you're watching and you want to give it a try, I'll bring the pencil. But here's the real twist. The only reason any of this works comes down to one thing. If you really want to understand why the universe chooses diamonds there and graphite here, watch the Gibbs Free Energy video. I wish this was real. You're gorgeous too. Don't worry. More useful, actually.